Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and I'm going to do a bit more support on straight line graphs. It is that topic that keeps on coming up, and I will continue making videos for as long as it is necessary. What I've got here is question 10 of this worksheet. Find the equation of the straight line that passes through these pairs of points. Let's start with the first one, 2, 5 and 4, 1. So let me write those up. 2, 5 and 4, 1. So it's possible to work out the equation of the line that passes through both of these coordinates. First of all, by finding the gradient. That's a good place to start. The change in y divided by the change in x. In other words, going from this point to this point, the y being the second ordinate of each of these, what's the change from 5 to 11? Well, that's an increase of 6. What about the x? 2 is going up to 4. That's an increase of 2. So the gradient is 6 divided by 2, 3. So far, so good. Now, to work out the equation of the line, we need to remember the general form of a straight line equation is y equals mx plus c, right? Where m is the gradient, and c is what we call the y-intercept. When you draw these graphs, the number at the end of this will always be where it cuts through the vertical y-axis, which is good to remember. Good to remember indeed. So let's substitute the gradient that I've got in for m for this particular question. So y equals 3x plus c. Okay, so we're already nearly there just by finding the gradient, because we know that y and x just stay where they are. We just need to work out what the value of c is, and then we've got our line equation. So let's grab a coordinate from above. Why not this one? It doesn't matter which one, but 2, 5, the numbers are smaller, easier to work with. So I'm going to take the coordinate 2, 5, and I'm going to substitute those numbers in for x and y. And once I do that, the only thing that I won't know is the plus c bit, which is exactly the bit that I'm looking for. Now remember, coordinates. This 2 is an x value, and this 5 is a y value. So let's substitute them in that order, replacing x with 2 and y with 5. Let's do it. So y becomes 5, x becomes 2. Okay, so all we need to do now is figure out, by doing maths to this, what c has to be. 3 times 2, 5 equals 6 plus c. What do I have to add to 6 to make 5? Or in other words, another method is just taking away 6 from both sides of this equation to get c on its own. 5 take away 6, minus 1 equals c. So the final equation for this question is y equals 3x minus 1. There you go. Let's do another one. Let me skip through a few. Why not part F? So 3, 5 and 4, 1. Doing the same method again. First of all, the gradient, or m as we labeled it. Change in y over change in x. What's happening from this point to this point? 5 is decreasing to 1. Decreasing to 1. So that means that the change in y is minus 4. It's really important that you get that right. When from this coordinate to this coordinate there's a negative change, that has to be reflected by a negative value of the change in y. 3 for the x values, 3 is increasing to 4. So that's just divided by 1. So the gradient is just minus 4. Okay? So easy to get that wrong if you don't pay attention to the fact that 5 is decreasing to 1. So getting our generic form out again, y equals mx plus c, or y equals minus 4x plus c, because the gradient, as we've said, is minus 4. Let's grab one of these coordinates. It doesn't matter which one, it really doesn't, but I'm going to choose 3, 5. Remember that 3 is the x value, 5 is the y value, and replace x and y in this equation form with those numbers. So y becomes 5, x becomes 3, and then plus c stays. Do some maths. 5 stays as it is. Negative 4 times positive 3 makes negative 12. What does c have to be to make this work? Let's get it on its own by adding 12, in this case, to both sides. 5 plus 12, 17 equals c. So the final equation is y equals minus 4x, in this case, plus 17. Now you can write that as y equals 17 minus 4x. Some mathematicians think that having a negative term at the beginning of the side of an equation is a bit messy. It really doesn't matter. Either one of these would be absolutely fine. Okay. So there you have it. A couple of questions on how we use the coordinates of a pair of coordinates that lie along a line to work out what that line's equation is. There is a lot going on here, but ultimately, as long as you're methodical, it shouldn't be too stressful. Feel free to watch this video as many times as is necessary. I wish you all the best in your endeavours. Keep up the good work, and for goodness sake, get your work done on Teams. I will talk to you very soon.